Welcome to The Explainer. I am so pumped you're joining us today because we've got a seriously fascinating topic to unpack. We're looking into this totally surprising overlap between massive AI data centers and the everyday public water systems that you and your family actually rely on. I mean, we all hear about the AI boom constantly, right? But the physical reality of how these systems run and exactly what they consume to do it is a story that's just barely starting to surface. So let's jump right in. Right out of the gate, we're tackling a pretty massive question. Could the giant, windowless buildings powering your favorite AI tools inadvertently act as disease spreaders? Now, I want to be 100% clear right up front. What we're exploring today is an emerging epidemiological theory. It's not a proven fact just yet. But as we put these puzzle pieces together, honestly, it's incredibly compelling and absolutely worth paying attention to. Section 1, the Wyoming Water Mystery, a hidden threat. To really get this puzzle, let's take a trip to Cheyenne, Wyoming. This is the home of a massive metadata center project known as GOAT Systems. And just wrap your head around the sheer scale for a second. 14 football fields. That is roughly the size of this single campus. So when we talk about AI infrastructure, we're definitely not talking about a little server closet. We are talking about industrial mega facilities that need a staggering amount of resources just to keep the computers cool and humming along. Now, before a giant place like this can officially power up, the crews have to do this routine thing called a fill and flush. Basically, they fill the building's brand new cooling pipes with water to clear out any construction grid, and then they flush that used water straight down the drain into the city's sewer. Sounds pretty boring, right? Well, a few months back, during one of these routine flushes, Cheyenne's local water utility ran a standard test for fecal contamination, and they found something they actually told reporters they had never, ever looked for before. What they caught in the water was this rare, antibiotic-resistant bacterium called Cupriavidus gilardii. And here's the crucial thing. While it might not be a huge deal for a perfectly healthy person, for anyone who is immunocompromised, think cancer patients or transplant recipients, it carries a staggering 30% mortality rate. Looking at past cases in medical journals, out of 32 known cases, 10 people died. So yeah, this is an incredibly dangerous bug for a very vulnerable group of people. Which brings us to a timeline that is frankly pretty concerning. The contamination was actually flagged and the dumping privileges were revoked way back in February and March of 2024. Now, the utility did a fantastic job cleaning it up, and thankfully, no human illnesses were linked to this specific event. But the public wasn't informed until late June. That's a 3-month gap. And the reason this matters so much is that Cheyenne, like a lot of modern cities, reclaims its wastewater and sprays it into public parks and golf courses as aerosols. If you're sitting on a park bench breathing in mist, you'd probably want to know what's in that water right away, not 3 months after the fact. Section 2. Deadly Lessons from History. Learning from the Past. Let's step back for a second. In the summer of 1854, a neighborhood in London was getting ravaged by a terrifying cholera epidemic. Everyone at the time thought the disease was just, floating in the bad-smelling air. But a physician named John Snow did something completely radical. He literally mapped out the deaths, and he noticed they were all tightly clustered around this one single public water pump on Broad Street. Snow convinced the authorities to just take the handle off that pump, and boom, the outbreak faded. He did this decades before we even knew what germs were. He essentially proved that when everyone's water comes through the same shared pipe, a single point of failure doesn't stay local. It travels. Okay, now take a look at this number. According to the Lawrence Berkeley National Laboratory, U.S. data centers drank roughly 17 billion gallons of water just for cooling in 2023. A single large facility can literally evaporate 3 to 5 million gallons of water in a single day. To put that into perspective, that's the water usage of an entire small American town. These massive windowless buildings have essentially become the modern equivalent of that heavily relied upon Broad Street pump. And honestly, it is genuinely eerie how history kind of rhymes here. Back in 1976, at the Bellevue Stratford Hotel in Philly, a warm cooling tower ended up growing a lethal newly discovered microbe, Legionella. The building's ventilation aerosolized it into the air, and it tragically killed 29 people, mostly older veterans. Fast forward to the Wyoming incident we just talked about. A local official actually pointed out that the data center's warm reclaimed water was being sprayed as an aerosol into public parks. It's the exact same dangerous mechanism. Warm recirculating water turned into mist, exposing vulnerable people. Section 3. The Data Center Theory, an Emerging Hypothesis. We're going to shift gears a bit now to an emerging hypothesis about a nationwide outbreak of a parasite called Cyclospora. Again, I want to be super clear. There's no hard evidence linking this directly to data centers yet, but the theory is absolutely fascinating. The idea is that data centers are not the origin, but they could be an accelerant. They don't create the parasite. Cyclospora exclusively comes from human waste. But because these massive AI facilities put such incredible stress on our shared, centralized water systems, they might act as a super spreader, basically taking a pathogen that's already in the system and accelerating its spread way further than it normally would go. So let's walk through exactly how this accelerant hypothesis would work, step by step. First, human waste carrying the parasite enters the wastewater system. Second, it goes through a treatment plant, but the chlorine actually fails to kill it. Third, that centralized water gets sent out to be reclaimed for reuse. Fourth, and here's the kicker, you plug in the thirstiest industrial machines ever built, data centers, which heavily stress and push that shared water system to its absolute limits. And finally, step 5, that reclaimed water potentially still carrying the living parasite gets sprayed right onto our landscapes or even agricultural crops. And what's truly wild is how perfectly adapted this specific parasite is to survive that exact journey. The CDC's own guidance explicitly states that routine chemical disinfection, like the chlorine we totally rely on to keep water safe, is unlikely to inactivate Cyclospora. It just shrugs off chlorine. It shrugs off freezing temperatures. It is uniquely suited to survive the exact wastewater treatment steps we count on, letting it easily hitch a ride straight through this reclaimed water loop. Section 4. The hidden costs of AI beyond the water. Now, to really grasp the big picture here, we have to broaden our lens beyond just water. The United States currently hosts roughly 40% of the entire world's data centers. Because America essentially built the AI industry, America is hosting the physical hardware. And what that means is American infrastructure, the shared grids and pipes in real towns across the country, is bearing the absolute brunt of the AI boom. And because of that, we're seeing some massive community pushback across a few key areas. On the electricity front, an independent monitor found data centers responsible for 63% of a recent mid-Atlantic price jump. That passes roughly $9 billion in extra costs down to regular people, though I should neutrally note that some studies do contest the exact impact on residential bills. Then there's the noise. The cooling equipment produces this chronic, low-frequency hum that the EPA actually associates with disrupted sleep and cardiovascular strain. Finally, air quality. When these places need backup power, they frequently burn diesel or gas, sometimes completely bypassing clean air permits and emitting pollutants right next to where people live. Section 5. Protecting your family. Practical steps. But look, knowing about these hidden costs is really only half the battle. If you're looking out for your family, here are some highly actionable safety steps straight from our sources. First up, if you're worried about the parasite on your produce, heat is the absolute only reliable killer. Cook your food to 158 degrees Fahrenheit. Just washing it won't do the trick. Second, pay attention when you're out and about. Avoid the purple pipes at parks and golf courses. Those signify reclaimed, non-potable water, so definitely keep kids and pets away from that spray. Third, if you're caring for someone who is immunocompromised, keep filtered or bottled water on hand, for sure. Fourth, if you get sick and it just drags on, standard stool tests are going to miss this parasite. You have to explicitly ask your doctor for a Cyclospora test. And finally, keep a very close eye on the elderly for severe dehydration and confusion, since they're the most vulnerable. So this kind of brings us full circle. The smart move here, what our source literally calls the Jon Snow move, is not to panic, but also not to look away. We need to be like Dr. Jon Snow with his map back in 1854. We need to pay close attention to the patterns in our own neighborhoods, ask the hard questions when we see massive new facilities plugging into our shared utility systems, and advocate for the vulnerable. Ultimately, we need to be ready to pull our own modern pump handles to protect each other. Which leaves us with this final thought. We are currently living through the absolute largest build-out of water and power-hungry machines in human history. They are quietly running the AI tools we all use every day, right in our own backyards. So take a look around where you live. How is your own community handling the quiet costs of the AI boom? Thank you so much for joining me on this explainer. Keep asking questions, and I'll catch you next time.